Hi everyone, let's take a look at a question on probability. In this question, we are given two events A and B, and we are given the following information. PA equal to 1 over 8. Probability of A union B is equal to 9 over 16. Probability of A intersect B prime is equal to 1 over 16. Part 1 wants us to find the probability of B. Usually when we are given questions on probability with a set notation such as the intersection, union, my preference actually is to illustrate this on a Venn diagram. With a pictorial representation, it will be much more easier for you to identify the region that you want. Let's draw a Venn diagram to illustrate the relation between A and B. So we have A here, we have B here. A union B basically will just be the probability of this plus with the probability of this. A intersect B prime will be this region which I'm shading. A intersect B prime. To find PB from this diagram, I can make use of this, subtract away this. It's just the total probability of A and B subtracted away the probability of A intersect B prime, which is this. 9 over 16 minus 1 over 16, which gives me 8 over 16 equal to half. For part 2 of the question, you want us to determine with a reason whether the events A and B are independent. To show independent, in fact, we have two formulas. The first formula is A intersect B must be equal to PA times PB. That means to say we need to show the left-hand side equal to right-hand side. The other formula which we won't be using now is like A given B, which is a conditional probability, equal to PA. Let's look at left-hand side of this equation, PA intersect B. From this diagram, to find PA intersect B, which is this particular region, I can just simply use the probability of A, subtract away the probability of A intersect B prime. The whole of probability of A subtract away this part. 1 over 8 minus 1 over 16, which give me 1 over 16. As for PA multiplied by PB, I can just use the values here directly. 1 over 8 multiplied by half. 1 over 8 multiplied by half, which give me 1 over 16, which happens to be the same. So they will be independent of each other. I can just write my conclusion here. Since probability of A intersect B is the same as PA times PB, therefore A and B are independent. Next part of the question says we are given a third event and the probability of PC is given by 3 over 8. And it also gives us the probability of A intersect B intersect C equal to 1 over 64. And C is independent of A. If they give us this information, I can just basically write down this relation directly. PA intersect C equal to PA times PC. For part 3, they want us to find the probability of A prime intersect C. A prime intersect C. Let's draw a quick Venn diagram to illustrate this. Now we have the events of A and C. A prime intersect C, basically I want it to be this region here. And we can see this basically will just be PC minus away probability of A intersect C. This part here minus away the intersection between A and C. And since we are given the information A and C are independent, we can just replace A intersect C with PA multiplied by PC. PC minus PA multiplied by PC. And we have all the information given to us. PC equal to 3 over 8. PA is 1 over 8. PC again is 3 over 8. Evaluating this, we should be able to get our answer as 21 over 64. All right, let's look at the last part of this question. It says, find the range of values of probability of A prime intercept B prime intercept C prime. Let's illustrate this on a Venn diagram. We have three events, events A, events B, event C. And A prime intercept B prime intercept C prime basically is the region that is outside this circle, is this particular region here. And if the question is asking to find the range of it, right, that means to say it's actually varying. And why does it vary? Perhaps, right, some of the values inside here is not being fixed. Right? If the values of this is not fixed, is varying, it will also cause the region outside to change. So our objective here actually is to first identify where is the region that is varying. That's our first step. Let's write down the information we have earlier on the probability. We have our probability of A is given by 1 over 8. Probability of B is given by half. Probability of C is given to be 3 over 8. And we also have probability of A intercept B. It will just be this times this, since A and B are independent. So we get 1 over 16. Probability of A intercept C, it will be just this times this also because it's also independent. And the thing is, for probability of B intercept C, right, I actually don't know anything about it because they never say anything about whether they are independent or not. So we cannot assume they are independent. So it's like I don't know. And probability of A intercept B intercept C is given by 1 over 64. So as I was saying, our first step is to identify the region that is actually varying. And looking at this, right, I can kind of suspect the part that is changing actually is this particular portion here. Because this part actually belongs to B intercept C, and we do not know the value. And it's not really fixed. Let's write down some of the values that we have first. So we have here is 1 over 64. In fact, actually, I can see the entire A is not changing at all. If you want, you can just like put it as a whole probability like 1 over 8. But maybe it will be slightly easier if we can find out all the respective region. Okay, so I will already suspect this should be the part that is varying. So I will just put like unknown X. And our second step is to fill out all these blanks. And some of the blanks will be in terms of X. And when we fill in the blanks, right, so for here, let's say I want to find what is the probability of this particular region here. It will just be probability of A intercept C minus away this part. Because A intercept C is given by 3 over 64. So working this out, I get 1 over 64. Similarly, here I will be able to get 3 over 64. Probability of A intercept B minus away 1 over 64. And this part here is left with 1 over 32. So you can see for the region, right, for all this region belonging to A, actually it's not varying, it's fixed. Likewise, we will be doing the same for this particular region. It will just be probably a B minus away this, which will give me a value of 7 over 16 minus X. And same thing here, it will just be probability of C minus the probability away this. You will get 21 over 64 minus X. And we shouldn't forget the part that I want to find, which is the part that is outside of the circles here. So the overall probability is 1. So I just use 1, subtract away everything else. I will be able to get a 7 over 64 plus X. Now the thing is, right, we know that actually X is varying. But because all these regions here represent all the different probability, and we know that probability actually range between 0 to 1. We can actually write down this. Let's say we take the variable, this is the one that is changing, that caused this to change. So we are looking at the variable here, here, here. So let's look at this part here first. So we have x greater or equal to 0. Probability can never be negative, and it also cannot exceed 1. But usually I will not, it's not really necessary to include the upper boundary, because later on when we are doing the solving the inequality here, definitely it will be a value that is below 1. But if you want to include it, it's perfectly fine also. So first part, x will be greater or equal to 0. The second part here, 7 over 16 minus x also greater or equal to 0. This part here will also be greater than 0. From here, we will be able to solve our inequality. Solving here, we will get x greater or equal to 0. This one will get x lesser or equal to 7 over 16. This will give me x lesser or equal to 21 over 64. And we can actually draw a number line to illustrate these three different regions here. This first part, I will get 0. Second one, we will be able to get 21 over 64. The last one we will get is 7 over 16. The region for this will just be from here all the way to here. This one will be from here to here. This will be from here to here. I want to find the region that satisfies all this inequality. So the region that I'm interested in, it will just be this portion here. So therefore, I know that x will range between 0 to 21 over 64. And finally, what I want to find actually is this portion here. This is the probability of A prime intersect B prime intersect C prime. And I will know that probability of A prime intersect B prime intersect C prime, it will just be equal to 7 over 64 plus x. And the range for this one that it can vary, right? It will just be between 7 over 64 plus x. The lower boundary is 0. So it will just be 0 plus 7 over 64. Upper boundary is 21 over 64. 21 over 64 plus 7 over 64. And therefore, my final answer for the range of A prime intersect C prime will just be between 7 over 64 and 7 over 16.